Have you ever accidentally dropped your pen or pencil on the floor when you're studying or when you're in class? Well, have you ever wondered how long or how fast it's going down? Well, today we're gonna answer that using the principle of mechanics.
Today, our group will present our project about freeform motion using a simple example, which is a droplet pencil. Freeform motion is a movement of an object when gravity is the only force acting on it, while a resistance is so small that it can be ignored. During the free fall, every object is accelerates downward at the same rate, which is approximately 9.8 meter per second square on Earth. This means that regardless of the object mass, gravity causes it to speed up as it falls. In this presentation, we will investigate how a pencil behaves when it is dropped from a certain height. These objectives of our presentation are simple. First, we want to understand the motion of a droplet pencil and explain why it follows the principle of free fall. Second, we aim to predict the time taken, the speed, and the impact when the pencil reaches the ground by using the equation of motion. Through the experiment, we can relate the theory of free fall to a real-life situation and better understand how gravity affects moving objects.
For the methodology, the first question is how long does it take for the pencil to fall? The second, what is the speed just before it hits the ground? The third, does the mass or type of pencil affect the fall? Answer 1. We have the displacement, which is 1.2 meters. Initial velocity is 0. Acceleration is 9.81 meter per second squared. Then, we use the formula S equals to ut plus 1 over 2 at squared. So, with all the information that we have, we substitute it into the formula and solve it, where the answer that we get is t equals to 0.49 seconds. Answer 2. We have the initial velocity, which is 0, the acceleration, which is 9.81 meter per second squared, and the time is equals to 0.49 seconds. And then we use the formula V equals to U plus AT, and we substitute all the values that we have into this formula, and we get V equals to 4.81 meter per second.
So continuing on to answer 3, no, in a free fall, all objects will accelerate towards the Earth at the same rate, which is 9.81 meters per second squared, and regardless of their mass. This means when a heavy pencil drop and a light pencil drop at the same time from the same height, they will reach the ground nearly at the same time, provided that air resistance is negligible. In conclusion, from our calculation, we've determined the time taken for the pencil to reach the ground and its velocity before impact. And this result shows that the motion of a falling object can be accurately predicted using the equation of mechanics. The simple everyday events prove that physics is always all around us. By understanding free fall motion, we can explain and predict the behavior of an object in real life, and making mechanics an important part of science and engineering. For reference, we've used a book made by Madam Diana from our branch, from our university branch, and we've used our own Madam Norpa notes that she's given us on during classes.